Hello class, in this video I will be introducing the inverse matrix for the class of 2 by 2 matrices. Let's begin. And before I can talk about the inverse matrix, I'm going to have to discuss the identity matrix first. So I'm going to let A be any 2 by 2 matrix. The identity matrix for a 2 by 2 matrix is the following. It is I is equal to 1, 0, 0, 1. And that's because A times I is equal to I times A, which is equal to A. And I'm going to show that to you right now. So I'm going to let A equal the matrix that I just highlighted in pink. I'm going to let I be the green matrix. And I'm going to multiply the two together using matrix multiplication. And that will look like the following. And after performing all of the multiplication and addition, the result will be the matrix A. So the matrix that I just highlighted in blue is the identity matrix for all 2 by 2 matrices. And why is that important? Well, the inverse matrix and the identity matrix share a special relationship. And it's the following. Given a matrix A, then the inverse matrix of A, which is labeled A raised to the negative 1 power, is the matrix such that the product of A and the inverse of A is equal to the identity matrix. And there is a formula we can use to find the inverse of a 2 by 2 matrix. So we're going to let A equal this matrix I just highlighted in green. Then the inverse is this matrix right here. And you may notice the scalar multiple that is being multiplied by the matrix. It is 1 divided by A times D minus B times C. And A times D minus B times C has a special name. That's called the determinant. And if the determinant is equal to 0, the 2 by 2 matrix does not have an inverse. And that is so because 1 divided by AD minus BC would actually equal 1 divided by 0, and that is undefined. Okay, so before we can find the inverse of a matrix, we have to determine if the determinant is equal to 0 or not. All right, so let's find the inverse of this example right here. So the first thing I want to do is I want to find the determinant. And the determinant is AD minus BC. So in this case, it would be negative 1 times 7 minus negative 3 times 5. So the determinant is equal to 8, which is not 0. So we know that an inverse exists. Okay, so now we want to find the inverse of A. So A inverse is going to equal 1 divided by the determinant, which will be 8, and then the formula says to interchange A and D. So in this case, that means we're going to interchange the -1 and the 7. So 7, -1. And I'm going to take the opposite values of the other diagonal. So this would be -5, and this would be a +3. So the inverse of A is going to be 7/8, -5/8, 3/8, -1/8.